Okay. Here is your lesson on how to do electron configurations. First of all, they look confusing, but I promise they're not. Okay. As soon as you kind of get a handle of what we're doing, it's not bad. All right. So you're going to be responsible for doing 3 types of electron configurations. Okay. These are just examples. I did oxygen. Okay. I did 3 types for oxygen. This one is orbital notation. I know I stopped the video because we use these boxes instead of the hash marks and the lines. So I wanted to make sure that you see it this way first. So orbital notation uses the boxes and the arrows. The arrows represent electrons and the boxes represent orbitals. For longhand electron configuration, we use these, the small letters up high, the exponents. Look right over here. I'm going to go ahead and move over here. The first number here, that is the energy level. Okay, that's why I've got it labeled here. Energy level, that is also the principal quantum number. So I told you I would try to give you a better definition for those. So when it says that the principal quantum number is the energy level, it's referring to this large number in front that we use for electron configurations. So these are principal quantum numbers. Those are also the energy levels. Okay. The letter that's next to these only have S and P's, but like I told you before, we have S, P, D, and F. Those are the 4 that we have. That is the orbital. We talked about the fact that S's are spheres, okay? And then the little number up here is going to be the electrons. That's how many electrons are in this one. There's 2 electrons. The S is also the angular momentum number, okay, which describes which orbital it is, S, P, D, or F. There are only 4, okay? And then lastly, you see an example of shorthand electron configuration. Okay, it's also called noble gas notation. That's whenever you go back to the last noble gas to begin your configuration so that it's shorter. Okay, so let's go into a little more of an explanation about these 4 orbitals. So you've got S, P, D, and F. When you're doing orbital notation, S's always have just one box. Okay, they only have one. The arrows inside are electrons, and they have to have opposite spins. They have to go up and down, okay? If they're in a box together, they have to have opposite spins, okay? So for S, there's only one orbital, that's the box, and 2 electrons. Those are the arrows. P has 3 boxes, or 3 orbitals, and 6 total electrons. D has 1, 2, 4, 5 orbitals and 10 electrons. And then F has 7. So these are the biggest ones. So let's look at where these things are on the periodic table. So I have 2 different ways to show you here. Your periodic table is divided up like this. These first 2 rows are going to be your S's. Okay. The middle is going to be your D. And then the ones on the end over here that I've got marked are going to be your P's. The F are these 2 rows down here. Okay, I actually have another one, and I will go back and forth between both of these several times, whichever one helps you the most. Okay, this one is labeled a little more in detailed with all the different sublevels. I know you can't see the F, so I'll scroll down. Okay, there are your F's. Okay, when you're looking at a regular periodic table, these numbers over here are your energy levels, okay? It's the energy level that you're on for S and for P. So if I'm up here, this is an S, 1S, 1S1 because it has 1 electron, and then this over here is 1S2, okay? This top one right here is an S, okay? That's included with the S's. The P's don't start till right here, okay? So both of these top 2, hydrogen and helium, are both S's. So as we move down here, we would be on energy level 2, okay? And these are 2s. It's 2s1, 2s2. This is the second box. Moving over into the P's, you still stay on the energy level that you see to the left. So you're still on energy level 2. There are 6 boxes in the P's, okay? So it's 2p1, 2, 3, 4, 5, 6. All right, so S's and P's stay on energy level. When you get to the D's, they go down by 1. So if you're on energy level 4, and you get over here to scandium, you actually drop down to 3D, okay? And so this one would be 40, 5D, 60. Now, maybe a good time, that's why this other chart that you see is written like this, because it's giving you that visual of when you get to here, if I'm on energy level 4, 4S, these are actually the 3Ds, okay? And then when you get to F's, they go down by 2. So it's 4F and 5F. But you can just remember what they are, though, because they never change. They stay this way the whole time, okay? Okay, so let's just do one and see how it goes. The first one I'm going to do is germanium. And I'm going to do orbital notation. That means I'm going to use the boxes, all right? So I think I'm going to do it over here on the periodic table. I don't know if I have room. Okay, so here's germanium here. Okay, and when you start for germanium, for all of them, you start at the very lowest energy level, which is 1s. Okay, so every time I'm going to start up here. Okay, so I'm just going to go 1s. Since I'm doing orbital notation, I'll draw a box with it. Okay, remember S's always just have one box. Since germanium's down here and I know I'm full, these 2 boxes are full. They fill up as you move down. I'm going to go ahead and put my electrons in for the S. Remember, both of those are electrons. I got 1, 2. Now I'm here. So I'm here now. So the next thing I put is 2, and I'm in the S section, right? So 2s. S's have 1 box. I have 2s1, 2s2, so both of those need arrows. And remember, those arrows represent electrons. They have to have opposite spins, so they need to be going up and down. Now I'm here. These just kind of read across like a book. So 1s2, 2s2, and then now I'm here in my 2 P's. Okay, this is the P section. So I'm going to write 2P. And I'm going to draw 3 boxes. Because remember, P's always have 3 boxes. And since this section is full, I'm going to put 2 electrons in each one. Now, I've got 6 arrows and 6 boxes. That's not a coincidence, okay? Each box is representing an electron that's being filled up, all right? So I've went all the way through here. Now I'm here. I'm just going to go down here because I'm a little running out of room, okay? Remember, S's have 1 box. 1, 2. Put in my arrows. Okay. I'm on energy level 3. I'll move right across to here. Now I'm in the 3 P's. P's have 3 boxes, 3 orbitals. And it is full. So I will fill it with electrons. Okay. Now I'm here. So I finished all these 3 P's. Now I'm here on 3s. Sorry. Here on 4s. S's have 1 box. Fill it up. Okay, so here's a little different. We haven't went into the D's yet. So as I cross over here from 4s, 1, 2, which I wrote down, I'm crossing into the D section. Remember, it goes down to 3D. If you need to look at this, you can. So here I am on the 4s, crossing into the 3D here, okay? So I'm going to write 3D. Now remember, D's had 5 boxes, 5 orbitals, so you have to draw all of them. Okay, and since germanium is all the way over here in the P section, I know these are full, right? There's 10 boxes, and they're all full. Okay, so here I am coming out of the D's. Now, I'm going back into the P section here. Remember, they stay on level, so I'm on 4, right? 4P. P's have 3 boxes. Okay, so when you're doing these, there was a rule that said you have to have an arrow in each box before you can go back and double them up in their boxes. All right, so for germanium, you see it's 2 over in the P section. 1, 2. So you only need 2 arrows. 1, 2. I cannot put these arrows together in this first box. Okay? You have to put 1 in each box before you can go back and start doubling them up. You can't have 2 in one box and have empty boxes. Okay? So this right here is the orbital notation for germanium, but I'm going to do an example down here. Okay? If I was filling this in, and if I had 3 electrons, they would have to go 1 in each box. It's the only way for that to be correct. All right, it would be incorrect if you put 3 in like this. It doesn't work that way. You have to put 3 in each box before you go back and start doubling them. Okay, so there's only one correct way to put 4 in, and only one correct way to put 5 in. All right, so make sure you know you have to put 1 in each box before you double them up. Okay, so that is for orbital notation. The other example was for longhand, okay, and it was for lead, so let's go find lead. Lead is Pb, and it is right here, okay. I'm going to do lead over here, and ideally you would want to do them all out in one line, but I don't have a lot of room here, and I want you to be able to see the periodic table as I do these. So again, you start at the top with longhand, okay, so I'm going to start right here again, 1s2. Now this time, I'm still going to do 1s like I did over here, but instead of drawing the box and the arrows, I'm just going to put a little 2 there to represent these electrons, 1, 2. See, there's a 2 here. There's 2 arrows in the box, okay? It's just a different way to represent it. Next is 2, so I'm here now, 2s. And again, I'm just going to put a 2 there to represent these 2 boxes right here. Next is 2p. There are 6 boxes there, and I'm going all the way down here to lead, so I know they're full. All right. Next is 3s. I have 2 there, 1, 2. Next is 3p. It's full, so there's 6 boxes, 6 electrons. 4s, 2. Now, this next one is 3d because I'm here again, right? And so I'm dropping down from 4 to 3. The d's drop down by 1, so this is 3d, 4d, 5d, 6d, okay? And there are 10 boxes. Means I've got 10 full electrons right there. After 3d, I'm here. I'm crossing into the 4p, okay? P's stay on level that you're on, so I'm crossing into 4p. Okay, back to here, 5s, 2. S is always 2. All right, I'm 4d. Okay, even though I'm on level 5, I go down by 1, so this is 4d. And 5p would be next. And it's full. All right, so here I am on 6d. Made it all the way down to here. It's going to, 6S. It is going to be 6S2. Now, when I cross over only on these bottom two right here, you guys have asked a lot of questions about these two F boxes down here. This is where they insert, okay? So this one right here inserts right here, okay? So this is, and they go down by 2. So if I'm on level 6, which I am, it would be 4F. These are 4F here. These are 5F down here, okay? So I'm here, okay? So after 6S2 would be 4F. And there are 14 boxes right here. That's where the 14 comes from. Okay. After I go through those, then I'm back up to here and I'm crossing into these D's right here. Okay. So it'd be 5D. 10 boxes. All right. I'm all the way over here to lead. I am in this section here. So this is 6P is a section I'm in. And I'm only 2 boxes into the 6P section. So 6P2 is what goes there. 6P2 would be your last thing. So this is the configuration for lead. Ideally, like I said, you want to try to write in a straight line, be more organized. Okay. The very last one to show you is shorthand. It is much, much easier and shorter to do, as the name implies. My periodic table is getting a little messy here, but let's see. Where are you, silver? Okay, here's silver. Okay, 47. When you do the shorthand, you get to go back to the last noble gas, okay? Remember, these are our noble gases right here. This whole row right here are noble gases, these guys. So I've been working my way forward as I've been doing these configurations. When you do shorthand, you start at the element you're given and work your way backwards, okay? So I'm going to go backwards this way and go to the last noble gas before my element. Krypton was the last noble gas before silver. If I go backwards, be krypton. And this is how you would write that. I'm just going to go ahead and write this one over here. I would put krypton's symbol in brackets. And then what that lets me do is I get to just start right here after krypton. All right, so I get to start my configuration right here with 5S. Okay, so it'd be 5S2. And then I'm moving into the D's. See, I'm not in the F's yet, so I'm still just moved straight to the D's. D's drop down by 1, so this is 4D. 5S, 4D. And silver is in this section. Okay, so I'm in the 4D section. 1, 2, 3, 4, 5, 6, 7, 8, 9. Silver's 9 boxes over. So 4D9. There you go.